Myself Nishan Kausal, and today we will solve our NSEM paper. So our first question is, write an algorithm for finding the root of fx equals to x square minus x minus 1 using the fixed point iteration method, and write output of the program slash algorithm of question 1b. So what will be algorithm of fixed point iteration? It will be start the initial guess of the roots, let's say x0. Okay, so we first assign the value of x0, that can be 0 anything. Then we take a tolerance value epsilon to determine the desired accuracy. Set the maximum number of iterations and max iterations to avoid infinite loops. Okay, initialize the iteration count to 0 so we can find out how much iterations we have done. Repeat the following steps until the convergence or reach the maximum number of iterations. What we have to do is we have to run this in a for loop. What we have to do is update x equals to fx plus x. Every time this for loop runs, x will be upgraded. We have to increment the iterations and check if x minus x0 is less than epsilon. Okay, if this condition is true, it means that we have a converged our solution and the current value is the approximate root. And if it is false, we will repeat these steps again. Okay, if a maximum number of iteration is reached without the convergence, then output message indicating that a method did not converge. Okay, so what will be its program? Its program will be like we have to define one function in which we will store its function with what is x square minus x minus 1. It is x square minus x minus 1. In this we will put values, right? We have defined another function for fixed point iteration in which we are taking initial guess as an input, tolerance value as an input, and number of max iterations. Okay, so what we have done is we have stored the initial guess in one variable current approximation, and we have created a one more variable previous approximation, and we have initialized iteration equals to 0, which we have seen in our algorithm. Okay, so if absolute of current approximation, so we have started a do while loop. In do while loop, we have what we have done is we have stored the current approximation value in previous approximation value, and we have updated current approximation value to the function of a previous approximation plus a previous approximation. Okay, so let's say previous approximation value is 2. So what we will do is 2 will be passed here. Its output will be 4 minus 2 minus 1. It will be 1. 1 plus previous approximation value was 2. So current approximation will be 3, right? Now what we have to do is if a standard absolute current approximation minus previous approximation is less than tolerance, return current approximation. Okay, so this is this condition. If x minus x0 is less than epsilon, return if true, converged. If it's false, what we will do is we will do iteration plus plus while iteration is less than max iterations. Okay, if we have not reached the max iterations, what we will do is we will print method did not converge within the maximum number of iteration and return current approximation. Okay, in main we have defined initial guess, tolerance, and max iterations, and we have passed it through fixed point iterator function, that is fixed point iterator. Initial guess, that is 1.5. Tolerance we have done up to 10 to the power minus 6, and number of max iteration we have done is 100. Okay, so if we have done the output equals to approximated root of root is std and pendle. Okay, so what will be its answer? Its answer will be approximated root 1.61803. So this was our question number 1. Now we will solve question number 2.